All right, here's a rectangle, but I want to show you how we get area of a triangle. I don't know if anybody's shown you this before. It's not really all that earth-shattering, but it's kind of interesting to see. Watch, if I do this, if I take that rectangle and I split it, I draw a diagonal, right, from corner to corner. Oops. Pretend it hits right there on the corner. And let's see. Remember what the original, if this was the base and this was the height, what would the area of the whole entire rectangle be? It'd just be the base times the height, wouldn't it? But look what I did here. I split it, didn't I? And now, and what have I formed? I formed two what? Two triangles, right? Tell me something about the two triangles. They're congruent to each other, right? Which means this triangle is how much of the original rectangle? It's half of it, isn't it? You ever see this? So, look, if I want to find the area of a triangle, then it's just the base times the height, which is the whole rectangle. But what am I doing? I'm just trying to find, that's my version of shading. Okay, I just want to find half of it, right? So the area of a triangle is just base times height divided by 2. A couple ways you could write it. You could write it like that. Tell you the truth, that's kind of my favorite way to write it. Or a lot of people prefer it like this. But 1/2 times the base times the height. It's the same exact thing. All right? So you take the base times the height divided by 2, or you take half the base times the height. That's the area of a triangle. Have you ever seen where we got that equation before? Again, I said it's not earth-shattering, but it's kind of interesting to see where that half came from. That's all there is to that. Let's do an example now with area of a triangle. This problem's a little bit different. Let's read it. It's kind of a word problem. Let's read what it says. You following along? Look at the example. It's on page 766, and it's example 4. It says the height of a triangle. The height of the triangle. Which one is that? It's that red one right there with the H next to it. Pretty obvious, okay? The height of the triangle is 5 centimeters more than its base. Well, do we know what the base is? No. It's B, though, isn't it? Whoops, that was supposed to stop right there. All right, so the base is B. It says the height is 5 more than the base. So how am I going to rewrite the height? What's the height then? B plus 5, right. I don't know what the B is, and that's fine, but I know the height is 5 more than the base. You with me? And now they also tell you the area. This time they actually tell you the area. You don't have to find the area. They tell you the area. So the area is 52. Let's see, I think it's in inches. Centimeters. It's in centimeters. So it's 52 square centimeters. Here's your information. They give you the height. They kind of give you the height. They kind of give you the base. They definitely give you the area. Guess what you have to find? Not the area, because they just told it to you. The base. And what else? And the height. Now, once you get the base, the height's easy. Just add a 5 to it. Correct? So let's do the formula. A equals. I'm going to write it like this. Is that all right? Base times height divided by 2. And let's see what we have. What do we know about the area? It's 52. So let's put a 52 in there. I'm not even going to put the centimeters squared. I'm just going to use the number. Equals the base. What do we call the base in this situation? B. What do we call the height in this situation? B plus 5. And all that is being divided by 2. Now we just have to do some algebra and solve for B. What's the first step you're going to do here? Yeah, multiply by, well, you could be squared, but I'm going to do this right off the bat. I'm going to get rid of the 2. All right? So multiply this by 2, multiply that by 2. What do you get over here? 104. Now, Zach, what are we going to do here? Right, b squared, what? 5b, good. Distribute, right? All right. Now, it looks like a quadratic. Yeah, I heard that. Oh, no, as soon as you see that. All right, well, I know, officially, I've told you all year that if you see these quadratics, I kind of expect you to know how to do that from Algebra 1. I should. But again, it's one of those topics probably taught more towards the end of the year. Some people get to it, some people don't. Next year in Algebra 2, this is not the first time I've told you this. I've told you this over and over again. Next year in Algebra 2, we're going to do a ton of this stuff. All right, so let's learn a little bit now so that when you get to it next year, you're like, oh, yeah, okay, I remember that stuff. That wasn't so bad. All right, so let's see what we do. What we want to do is a quadratic, so we want to set it equal to 0. So I've got b squared plus 5b. Now, what are we going to do with this? Let's chuck this to the other side. How do we do that? We subtract 104 from both sides and set that equal to 0. You okay with that? See, I just put this on the other side. And what's over here is 0. And I just kind of moved it over a little bit. Now, what in the world do we do here? Well, this actually does factor. Now, this is, unfortunately, it's not a real easy number that just pops in your head. but I'll show it to you right now. So watch, we put a b here and a b here. These multiply to be negative 104, and they add up to be positive 5. So one's going to be positive and one's going to be negative. Would you agree? Because they have to multiply to be negative, so a positive and a negative multiplies to be a negative. Now you just go through and you try a few numbers. I'll cheat a little bit and look in the book, and it's 13 and 8. 13 times 8 is negative 104, all right? And then when I add them together, it has to be a positive. So which one do I put? Do I put the 8 here or the 13 here?
13.
The 13, because when I add them up, it's got to be positive. So the bigger number has to be the positive. Okay? And there I go. I've got this thing right here. Watch what we just did. What do we call that whole idea of going from here to here? We give it one word. Factor. Good. Any of that coming back from Algebra 1? No? Did you remember seeing it at all? Okay. No? You guys never did that at all in Algebra 1? Okay, well, we'll do it in Algebra 2. Look, you can't say that about geometry. Have you ever seen this in geometry this year? Yes, every single one of you have seen this. Did we do a ton of it? No. All right, I didn't force you to do these things. I probably should have, but anyway, there we go. Now, what do? Both of these things are being multiplied together. Your answer is 0. So what can we do with both of them? Anybody from Algebra 1? Do you remember? Good. Set them both equal to 0. When we get to Algebra 2, we'll go through the explanation of why you do that. Right now, we're not going to do that. Now, you set them both equal to 0, so let's solve for b. So what's b equal to here? Negative 13. What's b equal to here? It's positive 8. So we get two answers, right? Circle them both? No, because look, we're trying to find the length. No, silly, you can't have a negative length. So you can't have negative 13 here, so you're going to just get rid of the negative 13. There's no way that a length can be negative anything. All right, so you're not going to use that. You're just going to throw it away, and you're just left with this. So b is 8, and what is the height? It is 13, right? So 8 times 13 is what? 52. All right, works out real nice. So, and we can just write this down. H equals what? 8 plus 5, which is 13. And there you go. There's your two answers. There's the base, and there's the height. It was a little bit different, wasn't it? This time they gave you the area, and they kind of gave you the base and the height. Not really. They gave it to you in terms of b, but you just do what it said. All right, you stick it in a formula, use that for the base, use that for the height. It's no big deal after that. Well, I don't know. Maybe this is a big deal for you. But hopefully, we've done these several times now. Hopefully, this is starting to sink in a little bit. All right, and I tell you what. Look, this may sound a little nerdy, a little geeky, but it doesn't matter, all right? What you should do every once in a while, everybody listening? What you should do, if you're going to be an honor student, and by in this class, you tell me you're an honor student. If you're an honor student, you know what you should do if you're not really sure about how to do this stuff? You should go on YouTube, all right? And you should do a search, and you should do quadratic equations, all right, or factoring quadratics. I'm telling you what, you wouldn't believe how much information there is on YouTube with teachers teaching all kinds of topics. Anything that you want to learn about, somebody's on there teaching about it. And some teachers are good, some teachers aren't so good. I found some pretty good teachers. I put a couple links on my YouTube site. All right, if you go to there, it's like subscribe or something like that. I'm still getting used to all the words, but I think I subscribe to their page or whatever. But if you go on mine, it's at the very bottom to the left. I got Khan Academy on there, and I got a couple other teachers on there. The other teachers do a pretty decent job, and what I think actually a real good job of explaining stuff. Some of the stuff might be beyond you. I think the one that I just put on last night or the night before teaches some geometry, Algebra 1 stuff, Algebra 2 stuff. Go to it and learn how to do this stuff. All right, don't just expect to just sit there in a class and just expect to get it all the time. You go out, grab it, go for it, okay? Go for that knowledge, and don't just sit there and let it happen to you. You follow me? All right, everybody say bye.